Hi, in this video we will solve another word problem for related rates. Here we have a water tank which is in the shape of an inverted circular cone. Well, let me just draw something, sketch something here for you. So it will be something of this form. Its height is 5. The radius of the base is 4 meter. There's some water in that, and this water is being drained out, so it goes out from the bottom at the rate of 1 cubic meter per hour. So then the question is what is the rate at which the level of the water, you see the level of the water is this height here, and what is the speed of that when the water has the level 4 meter from the bottom. Okay, so here after all those descriptions, hopefully you now have an idea of what are the variables or what are the quantities that we need to have a name for in this problem. So first thing is that, well, the volume of the water, because it is going to go smaller and smaller, it's draining out, so the volume of the water in the tank. So this will denote it by V. Well, another thing would be the level of the water from the bottom. Yes, so the level of the water from the bottom. This, let's denote it by L. Very nice. And what we know that the water is drained out, so the volume changes as time varies, and that will be at this speed, so negative 1 cubic meter per hour. Why negative? Because it's draining out, the volume is decreasing, it's getting smaller and smaller number. And how about what we are looking for is what is the rate of the level of water when it is 4 meter. So this is what we have. So we have identified, we have written down the given information. Now it's time to find relation between V and L. So first thing is that, well, okay, so this is the water. This is going to be a cone. The height of the cone is actually the level of the water L. But to find the volume of the a cone-like water shape body, we have to find what is the radius of the base, then pi r squared times L, and 1/3 of that. That is the relation between volume. So basically you have to know what is the volume of a circular cone. Here, this is a good formula, but something is bothering me, and that is, well, we didn't have any information for R here in this problem. And I don't like to bring in R because I want the V and L to be two variables, the only two variables in my equations. So now this is something I have to get rid of that R, turn it in something else. How do we do this one? Well, if you see the cut view of the cone, the tank, and the water, you will see two triangles like this. Well, let me just do it, a picture here again. And this is the water part, and this is the whole tank, yes? Now, these two triangles, which, by the way, this is L, this is 5, This is 4. These guys are the radiuses, yes. And this is what we have R here. These are two right triangles, and you can see that these are similar triangles. What does that give me? If you have two similar triangles, the ratio of corresponding sides would be equal. So this height of the bigger over the height of the smaller triangle is going to be equal to radius, or the base side of the triangle, bigger triangle, over the radius of the smaller one. Well, this gives us a relation between R and L. So indeed, you can write R as 4 over 5 of L. How is this going to help? Well, I have this equation. I will plug in 4 over 5 times L for R in this equation. So 1 and 2 together gives us that volume is 1/3 of pi 4 over 5 L squared L. Simplify a little bit. This will give us 1625 over 375 pi L cubed. Now that we have the relation, this is the relation. So let me write this here. 1/6 of 75 pi L cube. Then we can go ahead find d dt of both sides, because I want to find the relation between the rates or rate of changes. So this will be 1675 pi 3 dl dt L squared. Well, we can simplify again a little bit, like 16 over 25 pi dl dt L squared. What we have now, plug in the given values. What are the values? dv dt is -1. This is 1625 pi. dl dt is what we are looking for. And L squared is, well, at what L? L is 4. At that point, it is as. This means, again, that the rate of change of volume, the way the rate of change of volume and the level of water are related, it really depends to the level of the water. So the lower it goes, the relation will be different. So here is squared, I forgot that. Now I can solve this for dl dt, which will give us -1 over 16 times 16 over 25 pi. Well, this will be negative. Well, I'm just trying to simplify, well, not simplify, just write it in a better way, just to see what's happening. And this will be meter per hour. So 25 over 16 squared pi meter per hour. The level of water will go down. Why is negative? Well, that negative mentions, so negative sign tells us that L is decreasing. So it's going down. That's why. So if someone asks you at what rate the level goes down, so you can write that the level of the water in the tank goes down at 25/16 squared pi meter per hour when it is 4 meters. So going down is where this negative sign plays a role. Okay, so identify the quantities, variables,